So now we're looking at, in part 3, we're looking at a specific case where f of x is equal to e to the tx, right? So that's the function f of x. So our particular function for our binary alphabet is going to be f of xi is equal to e to the txi, right? And now we want to compute the expected value of f of xi. This is very simple, which is f of xi, which is with probability p, it takes e times t to the 1 plus the probability 1 minus p takes e times t to the 0, right? This is just 1. This is p times e to the t plus 1 minus p, which is p times e to the t minus 1 plus 1. So that's the expected value of f of xi. So question 4, which conveniently fit on the second half of the screen, asks us to use this inequality, this one right there, which states that 1 plus x is less than equal to e to the x, and it asks us to use that inequality to find a bound in this one. So it's pretty obvious from this that this portion here is going to be x, and that's going to be the one. So you have 1 plus this thing is equal to x. Therefore, 1 plus x is less than equal to e to the x. So what is 1 plus p times e to the t minus 1 from the outside, sorry, to the t minus 1. What is this going to be less than equal to? It's just e to the, this part is x, so it's p times e to the t minus 1. Therefore, since this is an expectation of f of xi, f of xi is going to be less than equal to e to the p times e to the t minus 1. Therefore, this goes in the box. Alright, so that's it for part 4 of question 4. Alright, so now we're in part 5, and I figured that since 3, 4, and 5 are all similar, I'm just going to put all of them into the same page. So now part 5 asks us to find expectation of f of xi, f of xi times f of x, f of x1 times f of x2 times f of xn all the way to f of xn in terms of the individual expectations, and then use the upper bound which we found in the earlier part, right? So first of all, from independence, let's just say f of x1 is equal to, no, we're trying to find the product, right? Not the probability. x2 all the way till f of xn is just equal to expectation of f of x1 times expectation of f of x2 all the way to expectation of f of xn, right? Let's just go there. This is equal to, what did we find from the previous part? Well, this is less than equal to, since each and every f of expectation, oh, I forgot to close it there, wow, okay, since each and every one of these is less than equal to e to the pi, e to the p times e to the t minus 1, well, that's slightly complicated, yeah. So each and every one of these terms is going to be less than equal to that. Therefore, the product of all the terms is going to be less than equal to this times e to the p, e to the t minus 1 times all the way to, okay, I should put the dots outside the brackets, all the way e to the p t minus 1. There are n of these, right? Since there are n of those and they are all the same thing, this is equal to e to the p e t minus 1 n, which is equal to e to the n p e t minus 1, which is equal to e to the mu e t minus 1, and mu is just equal to expectation of s. S is the sum of all those random variables. So the expectation of the product of all those is equal to the, well, okay, I don't really want to say mu yet. Mu is equal to the expectation of s yet, but you know that n times p is going to be the expectation of the sum of all the random variables. And that's it for question 5 of problem 4.